Hello guys, good evening everyone. Welcome to the session and welcome to the India's most comprehensive preparation platform, the BYJU'S Exam Prep, and welcome to the Atomic series. Yes guys, so to boost up your preparation for BARC and HAL examinations and many more to come up, as you know, after GATE and engineering services, there will be several other examinations that will keep coming up. You are already prepared for GATE, you are prepared for ESE, but yeah, you want more options, maybe GATE or ESE, but not up to that level that you expected, but still your preparation is done. You need to practice few more questions, you need to revise up, and just to boost up your confidence, we bring up the BARC and HAL. Already started, and few sessions have already been conducted. This is the next session, and in this digital electronic session, yesterday also I took a digital electronic session where we took up the questions of combinational circuits and logic gates, and as well as including K-maps and all those things. Today we talk about the very important topic, that is the sequential circuits, and of course few questions of ADC and DAC. But let me tell you that sequential circuits in any competitive exam, as you know, is very important for you. Very important for you. Okay, so let's boost up our preparation. Let's revise the thing through the question practice, and also guys, definitely do share this session to all your friends, to all your colleagues who are preparing for BARC, HAL. The exam will start from around 7th April and there's nearly 1 month, little more than 1 month left to it. So, try to be, just doing best in this examination. In case somebody new to this session, brief intro about me. This is your mentor and educator, Rakesh Talreja. I have secured the All India rank 9th in GATE exam, completed my Masters from the Indian Institute of Science, Bangalore, having trained more than 50,000 students in my 11 years of journey. Very good evening, very good evening all. Keep joining the session. My major area of expertise in technical will include control system, digital electronics, signal and system, and EMT. Other than that, I take up the maths and aptitude. No diaries. Right, good evening. Okay, fantastic. Let's move ahead. Okay, so guys, as I told you yesterday also, just a gentle reminder before we start up the question for the day. Yes, those who are also willing to prepare for the upcoming GATE 23 examination, or your juniors, okay, juniors are willing to prepare for GATE 23 or GATE 24. So what should be the strategy, the complete strategy? What is the right time to begin up that preparation, and what can be the tips and tricks from the BYJU'S experts? We'll take up this session on this coming Saturday, 5th of March at 8 p.m. That is just day after tomorrow, I believe. And this is going to be taken by me and Ashutosh sir. Right. So guys, do stay, just follow this session with the complete idea of the GATE 23 sessions. Acha ji. Other than that, one more thing let me add up. Okay, not only this how to start preparation, we will also be telling you what is some of the contents that is going to be immediately offered on the YouTube by the BYJU'S team. Yes guys, for all branches we'll do take up some sessions for GATE 23 and GATE 24 to bring you the concept clarity. Right now it's the beginning stage, so what is the main thing that you need to focus is conceptual clarity, right? So we bring upon another series, that is mastering GATE concepts. Okay, to learn the GATE concepts and also to solve the question. Also guys, this is tonight, just a reminder, I am again coming live at 10 p.m. I'm again coming live at 10 p.m. Right guys, so if you feel that you have little low score you are getting, as per your expectation is not fulfilled, you're getting low score, but still you have that dream that you want to go Indian Institute of Science or IITs, know how is this possible? Right, we'll discuss this in this session. Okay, tonight at 10 p.m. So please follow this. What are the different branches available that you are not aware about? What are the interdisciplinary branches which you may opt even with the low GATE score and get your dream completed of going into IIT or IIC? Otherwise, usually people will think more than 900 or 850 score, if you don't get, we cannot think about old IIT or IIC. No, we'll definitely try to think about these. Okay, let's see what is the score and where you can apply. Okay, let's move ahead. This is tonight at 10 p.m. immediately after, not immediately after this, but yeah, just tonight only 10 p.m. right? To get more updates about my sessions, to get all information, you can also join my Telegram group, guys. So yesterday PDF, actually just starting this session, I remember that yesterday I forgot to share the PDF. I apologize for that. Somehow I forgot, you know, when I'm starting this session I got to remember ki arey aap log ko PDF dena tha. So guys, don't worry, today's PDF and yesterday PDF, both I will combine, and today both the PDFs I will give you today. Right, both the PDFs I will give you today. Okay, in this Telegram group, Gate/ESE by Rakesh Talreja, you can join and get the PDFs and other updates also. And this is the question number 1 for tonight. Yes, guys, let's get started. Now back to the work. Quickly, let's solve the question. The digital circuit shown in the figure works and basically flip-flop, counter, take a synchronous counter, ripple counter, shift registers, all these types of cases we'll try to cover up. Some delay-based questions as well. The digital circuit shown in the figure works at what type of flip-flops? A very simple case. You are earlier given a D flip-flop, and you know for a D flip-flop, the next state Q plus is just equal to the D. Right, but what comes to the D? What is coming to the D? It is the output of the XOR gate. It is the output of the XOR gate where the inputs is X and Q. X and Q. So I just keep on telling you, name में क्या रखा है, नाम तो कुछ भी बोल सकते हैं. तो let's say, okay, let's say if you say X is equal to T, na, then you will get the clear idea. So what is the Q plus? It is T XOR Q, right? And T XOR Q is the functionality of which flip-flop? Okay, the next state, the transition equation, Q plus is equal to T XOR Q, okay, is the functionality of the T flip-flop. So this equation definitely gives you an idea that this is the T flip-flop. This is the T flip-flop. Correct answer for this is going to be option number C. Right, everybody? The correct answer is option number C. A very basic question on the flip-flop. Given the D flip-flop is a conversion of D flip-flop into T flip-flop using an external XOR gate. Okay, chalo. Moving ahead to the next question. What is the state transition diagram for the logic circuit shown below? What is the state transition diagram for the logic circuit shown below? Right, so state transition diagram questions also we can expect, na? Yes, for the previous question. I think comments are a little bit delayed. Now suddenly C is coming. Yes, guys, tell me for this one, what is the state transition diagram? Now this is a flip-flop, again a D flip-flop given to you, okay, and some external combinational circuitry, that is a 2:1 mux is given to you. Yesterday we also solved the question on the mux, and mux questions are usually simple to handle. Okay, so guys, what is the output of the mux? It depends on the select line. The select line here is A, and that is the input. Okay, that is the input that you have to, with respect to which you have to draw the state transition diagram. Acha. So very simple analysis that you can do here is, okay, very simple analysis that you can do here is, if the input A is equal to 0, if the input is 0, right, if the select line is 0, then the output of the multiplexer is equal to X naught. Okay, it is equal to the X naught, and now what is the X naught? X naught is coming from the Q bar. X naught is coming from the Q bar. Okay, X naught is coming from the Q bar. Sir, if A is equal to 1, if A is equal to 1, what is the Y? Y is equal to X1, and X1 is equal to Q. Now this is the output of the mux. I want to draw the state transition diagram. I want to represent the state of the flip-flop, the state of the memory device. Okay, so what is the Q plus? Acha. So what is the Q plus? For a D flip-flop, Q plus is equal to D and D is equal to Y, and the story of Y is already written in front of you. The story is Y already written in front of you. That means the Q plus is equal to Y. So Q plus is equal to Q for A equal to 1. Q plus is equal to Q bar for A equal to 0. Story finished, na? Right? Q plus equal to Q. It remains in the same state if the input A is high. It toggles if the input is 0. This is just like the complement of T flip-flop. This is working as reverse of T flip-flop. If the input is 0, then it will toggle, then it will complement. But if the input is high, it will not change the state. That happens in the reverse in the T flip-flop. So which of the state transition diagram represents this particular equation? Let's see that which of them represents this particular state equation. So for input 1, let's take the same state. Okay, input 1 same state. No, here there is a transition. Wrong. For the input 1, transition. Wrong. For the input 1, there is a transition. Wrong. For the input 1, same state. Perfect. This looks perfect. Right. For the input equal to 1, 0 to 0, 1 to 1. I come back to the same state, and then for the input equal to 0, I should toggle, right? For the input equal to 0, 1 to 0 toggle, 0 ka 1 toggle. That is the option number D. Perfect. Option number D is matching up as per our analysis of the circuit. Option number D. Correct. Yes, guys. Option number D. Yes, Shubhajit, correct. Chinmoy, correct. Manasi, correct. Option number D is correct. Okay, let's move ahead. Let's energize for the next question. Also, do keep on sharing the session so that all BARC HAL aspirants get the benefit of this. Okay, if you're getting the answer, if you're learning the concepts, do not forget to hit the like button, put your response, put your attendance, sort of, I can say, and let's follow the next question. Consider the following circuit involving a positive edge triggered D flip-flop. Positive edge triggered D flip-flop. Once again, a question with D flip-flop is very common in the exams also. Consider the following timing diagram. Let AI, this is AI, okay? AI represent the logic level on the line A. Logic level on the line A in the ith clock period. In what? In the ith clock period. Let A dash represent the complement of A. What is the correct output sequence on Y? What is the correct output sequence on Y over clock periods 1 through 5? Over the clock periods 1 through 5. Right, 1 through 5. That is input slash output, Manas. If that is given, usually we write input slash output if the device also has some external output. Okay. So guys, what is the output? What is the correct output sequence on Y? On this Y for the clock periods 1 to 5. Now please pay attention. The Y, okay, see what is Y? Y is equal to the next state of the device. When the Q plus is being represented as Y, that will be equal to D. Okay, that will be equal to D. Now to have the analysis of D, let's take the input. अब अगर input 0 है तो what is going to happen? यहाँ तो सिर्फ waveform रखा है मैंने. See guys, if the input is 0, this also goes 0, correct? Right? And if the input is 0, the toggle is 1. This is known as the Q bar. This is known as the Q bar. So 1 into Q bar is Q bar. 0 plus Q bar will be Q bar. 0 plus Q bar will be equal to the Q bar. Okay. That means, sir, what I can write ki if the X is equal to 0, what is coming on the D input is Q bar. And hence Y, which is equal to Q plus, I can say Y, which is equal to D, the next state of the flip-flop is equal to D, and D is Q bar. This is one of the equation, right? But sir, what happens if the X is equal to 1? If the X is equal to 1, let's again trace this equation. X is 1, so complement is 0. So the output of the lower AND gate is 0. But here you get A into 1, which is equal to A. So now you get D is equal to A. What comes here? A plus 0 is A. D is equal to A, and then Y, which is equal to D, will be equal to A. So then your output will become equal to the A if the input X is equal to the 1. Alan, I'm good. How are you? Right. So that's what is the analysis of the circuit with respect to X equal to 0 or X equal to 1. Now let's come here and try to solve this question. Okay. What is the correct output sequence on Y through the clock periods 1 through 5? एक एक करके देखेंगे. This is what? Let's take this. This is X equal to 1. Okay. If I start here, this is the first clock cycle starting. Let's do this. So what is the positive edge triggered? Yes, correct. This is the positive edge triggered. It's mentioned here also. Okay. So let us mark all the positive edges actually. Let me mark all the positive edges. The flip-flop will respond only to the positive edges. Okay, so when you see the first positive edge, guys, what is the value of the X? What is the value of X? Here, X is equal to 0, right? Now, second positive edge, if you see the second positive edge, X is again 0. Okay, third positive edge, X is equal to, sorry, this is not 0. I'm writing reverse. X is equal to 1 here. It's logic high actually. X is 1. Here also X is 1. But here X will be taken as 0. Okay, X will be taken as the 0. Now here X is again 1, here X is again 1. Just before the edge, whatever is the state of the input, that you should consider even in the ideal case. Okay, so अब अगर X 1 है, तो output is equal to A, right? Output is equal to the A. That means this is 0. So here the output should become A naught, right? क्या बोला था? Let AI represent a logic level on the line A on the ith clock period, right? So this was the 0th clock period, so A naught. Then x is equal to 1, you should get A1. X is equal to 0 पे क्या होगा? At x is equal to 0, y is equal to q bar, the complement of the previous state. The complement of the previous state. So previous state is A1, you will get here A1 complement. Then again x equal to 1. Okay, x equal to 1, just read this. Y is equal to A. So next, what is going to come here? This was 3rd clock period gone, so A3. Again x equal to 1. So output will be equal to A. Which A? A4. So output should be A0, A1, A2 omit हो जाएगा यहाँ पे. A0, A1, A1 dash A3, A4. A0, A1, A1 dash A3, A4. Option number A seems to be correct. Very good question. This is a very good question. I'll not call it as difficult, and I will also not call it as time consuming. This can be as per the BARC and HAL level also. A very good conceptual question. Analysis of the waveform, the timing waveform. It's a nice decent question, I believe. Nice decent question. Correct? All agreed? Option number A is correct. Option number A. Okay, that's all okay. Let's move ahead to the next case then. Yes, a simple question. If a counter having 10 flip-flops is initially at 0, what count will it hold after 2060 pulses? After 2060 pulses. Flip-flop having a counter having 10 flip-flops. So what is the count state? What is the total number of states? 2 raised to the power 10, which is 10 है ना? Yes, 2 raised to the power 10, which is 1024, which is 1024. Okay, so there will be total 1024 states. Okay, so it will first count from 0 to 1023. That is one cycle complete. Okay, that is one cycle complete. It will again count 0 से लेके 1023, again one more cycle complete. और total कितना हो गया ये? Okay, this is 1024 cycles. Because I am starting from 0, this is again 1024 and this becomes 2048. The question is asking you, what count will it hold after 2060? After 2060. Yeah, Rahul, you can message me personally on the Telegram. Let's discuss over there. And anyways, we'll bring upon some sessions that what you can do with the low gate score. If you have not extremely low, but if you have low gate score, like today only I am taking the session. Today only I am taking the session where we are going to talk about the IIT or ISC admission through low gate score. Other than that, also multiple sessions will come, and regarding to your personal queries, you can also talk to me in Telegram. Now 2048 ke baad again it will restart, right? Again it will restart. So what should be the answer? Yes. So 2060 guys, try to think. 2060 after 2060 bola hai na, तो minus 2048 is how much? Okay, this is how much? This is equal to 12, and 12 will correspond to how much? 1100. 12 will correspond to 1100. In the 8-bit, in the 10-bit format, it is 00001100. It should be the option number A, not the D. A. Most of you telling A, that is the correct one. So it's a simple logical question, but sometimes students little confused about the numbering. That is why I took this. Let's move ahead to the next question then. The above synchronous sequential circuit, yes, it's a synchronous counter where all the flip-flops are fed with the common clock. All the flip-flops are fed with the common clock. Is built using JK flip-flops, is initialized with the state 000, the state sequence for the next 3 clock cycle. Next 3 clock cycles, and initially you have to take 000, right? Yes, Anjali, but I think if you are really preparing for any exam, even if it is 2 seats, somebody low hai, not very low also, but even if it is 2 seats or 5 seats, somebody will get those 2 seats and 5 seats. Now, so why not you? Why not you can be in that somebody? So never look into the seats. Okay, that will always demotivate you, right? Just try. Maybe you are that top 5 or top 10 students. Somebody is there, and otherwise see, everybody will think low seats and nobody will prepare, right? Nobody. अच्छा, let me tell you one beauty also. हम कितना भी explain करें, but there will be many students who will be, just demotivated कि less seats and they are not very serious. So take the advantage. If because of less seats, many people are not interested or demotivated or less interested for the exam, why not you take an edge there? Just always believe that whether it is one seat, why not, worst case, even if it is one seat, why should not I fight for that one seat if I have the caliber? If I have already prepared for GATE ESA, little more revision I need to do. So always, try as per your best caliber. Chalo, let's come to the question. Okay. Now guys, what is this connection representing? What is this connection? Let me tell you very clearly. इसको एक बार separately discuss करते हैं. Let me discuss this separately. I have to take this. Just a moment. Okay. So whenever guys look into this. Okay. If you have a JK flip-flop. If you have a JK flip-flop, positive edge triggered or negative edge triggered, whatever it may be. Okay. If you have a JK flip-flop whose inputs are shorted, there are two cases I will discuss, whose inputs are shorted, then this JK flip-flop behaves as, what happened to the board? If the inputs are shorted, then this JK flip-flop will actually behave as T. How do you build a T flip-flop? Same method only, na? By shorting both the inputs, by commonly tying both the inputs. Achha. On the other hand, you should know this because, directly you should know these cases. Right? If you consider the JK flip-flop, again, be it positive or negative edge triggered, okay, where if the input is X to the J, okay, what you give to the K is the X complement, then what does this flip-flop behaves as? Can anybody say? Let me tell you that this actually behaves as the T flip-flop. Sir, how? Okay, what is the Q plus? For a JK flip-flop, Q plus is JQ bar plus K bar Q, which is equal to J pe aaya X, so X Q bar plus K bar. Now what is there on the K? K itself has X bar. K itself has the X bar. So you have X bar ka bar into Q. X bar ka bar is X, which is common. Okay, X bar ka bar X common, Q bar plus Q equal to the 1. That means Q plus is equal to X. Q plus is equal to X, just like Q plus is equal to D. Okay. So this behaves as a D flip-flop. So always remember, okay, whenever both the inputs of JK flip-flop are complement of each other, J being X and K being X bar, then it is just like a D flip-flop. These are the simple points that you should remember even while solving the question, right? And when both the inputs of JK are shorted together, then it is a T flip-flop. So let's come here. So I can say that this effectively behaves as the D flip-flop. Okay, I can write down this functionality as the D flip-flop, and for D flip-flop, the next state equation is very simple, so that at least little bit process is easier to solve, na? At least the little bit process is easier to solve. Okay, so now let's try to solve this here. Okay, let us try. I'm telling you this is a D flip-flop. The second one will be taken as the D flip-flop. I need to write down the count sequence Q2, Q1, Q0. Acha, because this is the D flip-flop, this behaves as the D flip-flop. So what is the Q1 plus? What is the Q plus? Is equal to, let's suppose this is X. Let's suppose this is the D input. So Q plus is equal to X and X is equal to Q2. Guys, means whatever is the current value of Q2, whatever is the current value of Q2 will become the next state of Q1. Okay. Acha ji. Okay, so let's start here with 0, 0, 0. Even if the initial state is not mentioned, then you should have the habit of writing 0, 0, 0 always. If the Q2 is 0, okay, if whatever is the value of Q2, that will become the next state of Q1. So just right shift, and next we need to find. Rest हमें find करना पड़ेगा. So for rest of the thing, I need only the next 3 clock cycle analysis. अब देखो, what is Q2 plus? उसके लिए हमें देखना पड़ेगा what is the J and K input. So what is the J? It is Q1 bar. Q1 is currently 0, तो 0 का bar 1. What is the K? K is coming from Q0, Q0 0 है. Guys, J1 and K0, J1 K0 represents the set state, na? Represents the set state. J1 K0 represents the set, so Q2 will be set. Let's come to this Q0 flip-flop. What comes here is Q1. What is Q1? 0. यहाँ पे क्या आया? Q0 toggle. What is Q naught bar? What is the Q naught bar? Q naught is 0, so 0 ka bar 1. J0 K1. Sir, what is J0 and K1? It is the reset state. It is known as the reset state. Okay, so this will be reset. So next state should be 100. Next state should be 100. So I am left with option number C or D. But solve kar lete hain, pura kar lete hain. So 100. Now next, again, whatever is the current value of Q2 will become the next value of Q1. Will become what? Will become the next value of the Q1. Will become the next value of the Q1. Okay. अच्छा, इसके इक्वेशन को भी सिंपल कर सकते हैं क्या? What is the Q naught bar? Let me try. What is the Q naught bar? It is equal to J Q bar. J Q bar मतलब Q naught bar plus K bar into Q. What is coming to the J? J is equal to Q1. So this is Q1 Q naught bar plus K bar plus K bar. K पे क्या आया? Q naught का bar. Okay, Q naught का bar will be Q naught bar Q naught here. Then Q naught plus Q1. Yes. So this becomes Q naught plus Q1. और कर सकते हो. You can write it as the or of Q naught Q1. Right? तो इसको भी हमने simple कर दिया. Now, what is the or of Q naught Q1? 0 0 का or 0. So write down 0 here. If you want, this is optional. Otherwise, you can play with the binary bits also. Right? Okay. Only thing is Q2 का analysis करना है. तो everybody, what is this Q naught? Q naught का current value 0. What is coming here is Q1 ka bar. What is the Q1? See, current value. This is the next. This is not come up. This is the next state going to come. What is the current value of Q1? Q1 ka current value 0, तो उसका complement हो जाएगा 1. So you take 1 here. Right? J1 K0 again set. J1 K0 again set. So next should be 110. Are you getting it? Next should be 110. तो option हो गया C. But पूरा solve कर लेते हैं. Let us tally this. Next should be 110. Option is C. But let's solve it quickly. Now this is right shifted. What is the OR of 10? देखो, what is this? Q naught Q1 OR gate है ये. Okay, so Q naught Q1 10 का OR is 1. Only thing you need to decide is Q2. So let's come everyone. What comes here? J is coming from Q1 bar. Q1 1 है तो उसका complement 0. K is coming from the Q naught and Q naught 0. That is the current. ये तो आने वाला है. This is not come. This is the next state going to come. So current will be 0. Okay, so this comes 0 here. J0 K0 guys. J0 K0 J0 K0 same state. Okay, when J and K are both 0, it represents the same state, so 1 will remain to be 1. Earlier it was 1, will remain to be 1. Next state is 111. That's it, option number C. Okay. Option number C. That's it, done. Okay, what is Shiva telling me? Why not first JK flip-flop also? Because there are inputs. Na, Shiva. देखो, ध्यान देना very carefully. What is coming here? Just read this. This is Q1 bar. And what is on the K? It is Q naught. They are not the complement of each other. One is Q naught and one is Q1 ka bar. Q1 ka bar. Okay? Okay? Shiva Ravichandran. So they are not the complement of each other. They are the complement of some different variables. So of course that not to be counted. Okay. Chalo. So this is done. Option number C is obtained here, and we move to the next question. Then, sir, what is this flip flop known as? What is this flip flop known as? Okay, the clock is only given to the LSB. Okay, all the T flip flops are high. Clock is only given to the LSB flip-flop, and the output of every flip-flop, whether Q or Q naught, it could be any of them, output of every flip-flop serves as the clock of next. Output of every flip-flop serves as the clock of next. So basically ripple counter. This is what is known as the ripple action, propagating action. Right, this is the ripple counter, everybody. Now if this is the ripple counter, in the case of ripple counter, always remember, in the case of ripple counter, always remember a technique, just one connection. If it is Q2 negative edge, just if you remember one thing, answer is all. If you take the clock, okay, if you take the clock Q2 negative edge, it is a up counter. Just one thing you can remember. There are several methods to remember this. One keyword I tell you, Q2 negative edge. Q2 negative edge. It should be up counter. It should be up counter. Okay. Acha. So if you reverse, sir, if I reverse any one of them, if I take Q and positive edge, किसी एक को change किया, down, right? Okay. If I take Q negative, if I change again any one of them, up, right? Or Q bar, sorry, Q bar to positive to ho gaya hai, Q to negative to ho gaya, I'm sorry. Q is done. So now Q to negative ki jagah, if I take Q bar and negative, Q bar negative remains negative. So again it should be down counter, right? Q bar positive, up counter. Like that you can remember, right? Right? Yeah, that's what Shubhajit is coming up. Q bar to positive. Moral of the story is, if you change either Q or if you change either the edge, then the nature of the flip-flop will change. Okay? ठीक है? Yes, Rahul, why not? Very much possible if you again decide and kill it up. Okay, so what is the connection here? Q bar to positive edge. Q bar to the positive edge. Q bar to the positive edge should be up counter. Q bar to positive edge is shown here. Okay, so because of the Q bar to the positive edge, the device is positive edge trigger, it should be a up counter, and because it is a up counter, the next state will be 011 plus 1, that is 100. Matlab next state 011 is 3, 3 plus 1 is 4, right? 4, and the correct answer is option number B. Correct answer is option number B. Shivajit, you can even take it like that also. Whatever, there can be different terminology. You can just remember one point, Q to negative edge or sign, opposite sign, same sign. There are different ways to remember. I agree with you. Okay. Okay, done. So the correct answer is option number B. ये तो एकदम simple था. Ripple counter में we can expect different good questions also. This is one. Next state आ गया केवल. It's a up counter. So suppose if it was down counter, if the question was like this, Q to positive edge, Q to positive edge is a down counter, तो 1 के नीचे आएगा 2. Then the option will be 0, 1, 0. Then it will be A in that case. Correct. Chalo. In that case. Next question. Okay. The circuit shown consists of JK flip-flops, each with an active low asynchronous reset. Active low asynchronous reset. Okay. Active low asynchronous reset. The counter corresponding to this is the counter corresponding to this. So again guys, the output of every flip-flop goes to the clock of the next flip-flop, and it is a ripple counter. Sir, what type of ripple counter, up or down? Sir, what type of the ripple counter? So the connection here is Q to negative. That is the only thing you have to remember. Q to negative is up. Again I repeat, if any one of them is changed, then up to down ho jayega. If both of them are changed, again it becomes up. Q to negative edge, it is a up counter. Always just remember one thing, Q to negative edge, up counter. Because this is the up counter, so definitely this is discarded. Right, it has to be up. Whether it is modulo 5 or modulo 6. Now, if there is no reset thing, suppose if there was no reset functionality, if there was no external hardware, then it's a 3 flip-flop connection, so it will be a modulo 8 counter. Okay, but the flip-flop is going to be reset in some of the intermediate state, and what is that? So active low reset pin. So what is coming to the reset? Okay, reset is derived as the output of the NAND gate. Output of the NAND gate. Suppose the output of the NAND gate here is X. And because of the active low reset, okay, whenever X is equal to 0, if X is equal to 0, okay, see, it is connected to all the flip-flops. You have to see very carefully. In some of the questions, what they can do is, they can connect the output of the NAND gate maybe to only 2 of the flip-flops, not to all. You have to be very careful in looking into that. So if X is equal to 0, it goes to all flip-flops here actually. Okay, so all flip-flops will reset. Now, X equal to 0 hoga kaise? X is equal to 0 hoga kaise? Now, X is the output of NAND gate whose inputs are Q2 and Q0. Q2 and Q0. When is the output of NAND gate low? If both inputs are high, right? Output of, we all know that output of the NAND gate is low if all inputs are high. This is just going to behave as the complement, not of the AND gate, the complement of the AND gate. So if all the inputs are high, then only the output of the NAND gate will be low. If any one input is 0, the output of the NAND is always high. So हमें low मिल जाएगा if all inputs are high. So what are all these inputs? All inputs मतलब Q2 and Q0. So Q2 and Q0 both should be equal to the high, sir. Q2 and Q0 both should be equal to the high. Q2 and Q0 both should be equal to the high. अच्छा जी. Okay, Q2 और Q0 दोनों को high करना है. Okay, so now have a look into this table. Right, I start with Q2, Q1, Q0. Right, and I start with the 0, 0, 0. What is the nature of the counter? Is the up counter. Right, so you have 0, 0, 1, and you have to keep a track of Q2 and Q0. Both should be high. Q2 and Q0. Okay, अभी दोनों high नहीं है. So just keep on counting up. 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1. Next state is 5, 1, 0, 1. So what happens here, guys? At 1, 0, 1, this is the state where Q2 and Q0 are high for the first time, and here X will become 0, and if X becomes 0, all flip-flops reset. So what is the next state? If all flip-flops are going to be reset, so next state is 0, 0, 0. That means the state repeats now. The next state is 0, 0, 0, and that is the repetition of the state, no doubt. That is the repetition of the state. Okay, repetition of the state. Acha ji. Now 1, 2, 3, 4, 5, 6. Is it a modulo 6 counter? Okay, ये तो repeat है छोड़ दो. Is it a modulo 6 counter? Now ध्यान देना. What type of reset is given? Asynchronous. What is the meaning of asynchronous reset, guys? That this particular reset pin is not synchronized. Okay, with the clock. It will work independent of the clock. Okay, that means it will not wait for the next clock edge. As soon as the X becomes 0, okay, the flip-flops will reset. That means this is that state that is to be neglected. Okay, this is not to be counted. This is not to be counted because as soon as you get 1, 0, 1, X is 0, all the flip-flops reset immediately because it is the ideal case, no delays are given. So all flip-flops are reset immediately and you get 0, 0, 0. So this state occurs but for a very small amount of time, and hence it is not a valid state. What do I mean by valid state? When it remains active for one clock cycle. For one clock cycle. So this is not a valid state. So how many valid states are there? 1, 2, 3, 4, 5. It's a modulo 5. It's a modulo 5 and definitely up counter. The correct answer, my dear students, इसका जो correct answer होगा modulo 5 up counter, option number A. Option number A. Okay? It's the modulo 5 up counter. Modulo 5 up counter. It's the modulo 5 up counter. Okay. Let's move ahead to the next question of the day. Okay. What is the doubt that is coming up? See, it depends, Vaishnavi, how they are cascaded. In very simple language, I can answer is, have a look into this next question. Okay, in very simple language, what I can answer you is, let's say it's just a mod n counter. Based on the connection, you decide what is the mod number. So if it is a mod n counter, the output frequency, suppose MSB frequency, is the clock frequency divided by mod number. Vaishnavi. If it was synchronous reset, synchronous counter नहीं आ रहा था. Yes, if it is a synchronous reset, let me specify कि अगर question में same question, but if they mention synchronous reset, then the answer would be mod 6. Why, sir? Why? Then the answer will be mod 6. But ऐसा क्यों? क्योंकि अगर synchronous reset होगा, if it is a synchronous reset, so all the flip-flops will reset at the next clock edge. The reset will also work in synchronization with the clock. So all the flip-flops reset at the next clock edge. So this will remain 101 will remain active for one clock cycle, and hence it is a valid. Hence it is a valid state. So then one more state will be counted. So always asynchronous reset or synchronous reset, there will be a difference of 1 in the answer. In the figure below, U1 is a 4-bit binary synchronous counter. देखो synchronous counter का फंडा अलग होता है. We know what is a synchronous counter, in which all the flip flops are getting the common clock, right? With a synchronous reset. So the meaning of synchronous, okay, with clear input is that the clear input or the reset input should also be synchronized with the clock. So both are, you should clearly know. Q0 is the LSB, Q3 is the MSB. The figure represents what? The figure represents what? 4-bit binary synchronous counter. Of course, if nothing is mentioned, so we'll take it as up. There's no data mentioned here, so we'll take it as a regular up counter. Okay, now guys, see, it's just going to be clear. Okay, what is the clear input? That is the X. The clear input is X, right? So X0 kab hoga, right? If X is equal to 0, the device will reset. The device means the entire counter will reset. The device resets, right? X is equal to 0 kab hoga? X is equal to 0 kab hoga, right? If this is Q2, so if Q2 is equal to 1, if Q2 is equal to 1, right, 1 ka toggle 0 will come here. If Q2 is equal to 1, so the very simple case I can write down here, that is the Q3, Q2, Q1, Q0, that is 0 0 0 0, that is 0 0 0 1, that is 0 0 1 0, 0 0 1 0, 0 0 1 0. Q2 1 हो गया, right? अच्छा sorry, Q2 चाहिए ना मुझे. Okay, we'll keep moving. 0 0 1 1, 0 0 1 1 0 1 0 0. हमें Q2 देखना था, and Q2 is high here. If the Q2 is high na, now here this Q2 goes high. If the Q2 goes high, the X goes 0, and the next state will be 0 0 0 0. The next state, sir, will be 0 0 0 0. That is the repetition, but that next state will come after. Yes, I can write like that. The next stage is 0 0 0 0 on the next clock edge. On the next clock edge. अच्छा, इसका क्या मतलब हुआ? This will remain active for 1 clock cycle. Why on the next clock edge? Because the clear pin is also synchronous. It will work on the next clock edge only. So what is the mod now? Okay, this is 1, 2, 3, 4, 5 to be counted. ये तो repetition है. So total mod 5. So this time it should be mod 5. Okay, that's what I explained you in the previous slide also. If it was asynchronous reset, very carefully you have to read. If it is asynchronous, then you write down the mod 4 answer. Isn't it? Then you write down the mod 4 answer. ठीक है जी, बहुत ही बढ़िया. This is done. Okay, this is done. Let's move ahead to the next question. Yeah, so this is a good question coming up. What is the frequency and duty cycle of the output Y when the clock frequency is 1 megahertz at 50% duty cycle? What is the frequency and duty cycle of the output Y? It's a good question. ठीक है. देखो, the first D flip flop is positive edge triggered, the next D flip flop is negative edge triggered, but both are fed with the common clock. The clock frequency 1 megahertz and 50% duty cycle. Okay, and yes, let's name this. Okay, let's suppose this is Q1, this is Q2, so this is Q2 bar, this is Q1 bar, and Q2 bar goes to the first D flip flop. Right? So let's write down the equations. Now what is Q2 plus? what is Q2 plus is equal to D, and what is the D input there is Q1. Let's say this is D2. Let's say that is the D2. So yeah. Okay, what is the Q1 plus? Q1 plus is again equal to D1. Okay, this is the D1, and D1 is the Q2 ka toggle. Okay. Yes, even CS students can follow na programming wala. ठीक है? Now what is the frequency and duty cycle of the output Y? चलो बनाते चलेंगे हमें. First, to have a reference, let's draw the clock period also. Let's draw the clock waveform also. Here we have to take into both the positive and negative edges, because one of the device is positive edge triggered, another one is the negative edge triggered. Okay, we have to monitor both positive edge, negative edge, positive, negative, positive, negative, positive, negative. Acha. Initially, let's start both the outputs as 0, 0. Initially, the device is reset. Okay, both the outputs are 0, 0. So Y will be equal to 0. What is actually Y? Y is equal to Q1, Q2. Whatever may be the next state of Q1 and Q2. Let's write it as Q1 plus Q2 plus. Okay. तो पहले हम एक एक करके वेवफॉर्म बनाएंगे. You know, for this systematic approach, let's draw the Q1 and let's draw the Q2. This is the clock waveform. What is the Q1 waveform? What is the Q2 waveform? And then we will consider the AND of them. Now, Q1 will be active on the positive edge of the device. Okay, well, positive edge. What is Q1 plus is equal to Q2 bar? What is Q1 plus is equal to Q2 bar? ये एकदम ध्यान देते हुए चलना. Okay, so initially we both start with the 0. We both start with 0. What is the value of Q2 right now? Q2 is 0. Okay, Q2 is 0. So what is the Q1 bar? Q1 plus is Q2 ka complement, 0 ka complement 1. So on this positive edge, this becomes 1. Try to follow my words and the waveform. Okay, on this positive edge, Q1 become 1s. Now, jaise negative edge aayega, who becomes active on the negative edge? The second flip-flop. Okay, so we'll now check the transition of Q2. What is the Q2 plus is Q1. So Q1 1 ho chuka hai. Okay, this will remain the same state up to the next stage. And what is the Q2 plus? Let me write down the equation here also, guys. Okay, Q1 plus is Q2 ka bar, but Q2 plus is directly equal to the Q1. Directly equal to the Q1. Right. So Q1 agar 1 ho chuka hai, right? So this also is going to become, ye to next stage tak change nahi hoga. This also is going to become 1. Correct? This also becomes 1. Right. Now the next case. Now this is next positive edge where Q1 will be active and Q1 plus is Q2 ka bar. So what is the Q2? Now Q2 ko yahan tak disturb nahi karenge. Q2 is currently 1. So 1 toggle, 1 ka bar is 0. So this goes 0 and will remain at 0 up to the next positive edge. Now comes the next negative edge. Negative edge pe Q2 will change. Q2 plus is equal to Q1. So sir, what is the value of Q1? 0. So this will toggle. Right. Now moving ahead, positive edge पे Q1 को चेंज करना है. तो what is the Q1 plus Q2 का बार इसको यहां तक 0 रखेंगे. 0 complement is 1 and it remains to be 1. Negative edge Q2 will work. Q2 plus is equal to Q1. So what is the value of Q1? 1 हो चुका है. So this also becomes 1. Remains up to the next negative edge. Sir, what does this mean? There is the repetition period also. So because both the waveforms are repeated, now let's finally draw the Y waveform and conclude the answer. What is the Y waveform? Y, which is Q1, Q2. What is the waveform? See, initially both are 0, right? 0 into 0 is 0, right? Now you have 1 into 0, still 0. 1 into 0 is still 0. Right? ये देखना है. This is the period where both the inputs are 1, 1. Okay, where both the inputs are 1, 1, so Y will be equal to 1. Again, you have 0 into 1 case, 0 into 0 case, 1 into 0 case, finally again 1 into 1 case, correct? So, again when both the inputs are 1 here, okay, and it is going to be only up to this next stage because we know repetition ke baad, this is going to again become 0. Q1 plus is Q2 ka bar. Okay, now this is the output waveform. So what is the frequency and what is the duty cycle? Can't we comment? What is the frequency and duty cycle? Why not, sir? Let's try to comment on this. What is the frequency and duty cycle? तो पहले time period लिख लेंगे. What should be the time period here? Okay, what should be the time period of this waveform from here to here? So how many clock edges? Okay, if you see from here up to this particular point, okay, so negative edge to negative edge हो रहा है. This is 1 t clock, this is one time period of the clock. Negative edge to negative edge, this is one more time period of the clock. Okay, so this is total equal to 2 times the clock period. This is total equal to 2 times the clock period. This is total equal to 2 times the clock period, right? That means the time period of the Y waveform is 2 times the clock time period. So what is the frequency of the Y waveform? Frequency reciprocal of the time. So 1 upon 2 frequency of the clock. What is the clock frequency given to you guys? Clock frequency given to you is 1 megahertz. Half of 1 megahertz, 0.5 megahertz, or that is 500 kilohertz. That is the 500 kilohertz. That is the 500 kilohertz. अच्छा, अब duty cycle कितना होगा ये भी निकालेंगे. So what is the duty cycle of this waveform? It is very clear that this particular portion, how much is this? Okay, this much, इतना portion. This is t clock divided by 2, half of the clock time period. This is t clock divided by 2. Okay, so on time period, अब duty cycle निकालने पे आ गए हम. So when I am calculating the duty cycle, that will be the on time period divided by the total time period of the Y, and in percentage multiply by 100. On time period is clock time period divided by 2. Total time period is 2 times the clock time period. So effectively 2 and 2 denominator multiply, 100 by 4, 25%. 25%, and it is very clear from the picture also कि 50% तो नहीं दिख रहा है. It is definitely 1/4 on time period. So 25%, 500 kilohertz के साथ option number B. Option number B. Yes, Shubhaji, the very good question with respect to the timing analysis, duty cycle, frequency and all. Right. Option number B, correct option. Option number B being the correct option. Option number B. All cool. Moving ahead to the next. Case. Yeah. One more delay based good question, good analysis question. इसको भी देखेंगे. What is the maximum clock frequency at which the following circuit can be operated without timing violation? Without any timing violations. Assume that the combinational logic delay is 10 nanoseconds. Okay, इसका जो delay है that is 10 nanoseconds, and the clock duty cycle varies from 40 to the 60%. So how to solve this question? Okay, combinational logic delay is given. That means what is the TPD for this one? Okay, see, how do you write down the propagation delay of a flip-flop? It is actually clock to Q. TPD, or that is also known as the T clock to Q. The time from the arrival of the clock edge up to the time the output is produced, 0 लेना पड़ेगा, और इसके लिए भी 0, because nothing is mentioned. T clock to Q, will take it as 0. Only delay is mentioned for the combinational circuit. Okay, what is the maximum clock frequency at which the following circuit can be operated? अच्छा, again ध्यान देना, one of the flip flop is positive edge triggered, another one is negative edge triggered. Okay, is negative edge triggered. Okay, so how to, अरे यहाँ पे there is some error. These are looking to me as a reversed. This is the input D, output Q, input D, output Q. Now what should happen? Nana programming, why you're thinking like that? What should happen within the one clock period? Okay, this is the first positive edge, then there is a negative edge, then there's a positive edge. Okay, so the propagation delay of the flip-flops is not given. So I've taken it as 0. Given hona chahiye tha, but that is not given. No problem. So guys, please the flip-flops are ideal. So see, what happens when the positive edge comes? This flip-flop is active. The first flip-flop is active and it will produce the output in 0 time. It is the ideal case. Okay. But then for this input, for the output of the first flip-flop to propagate to the input of the next flip-flop, the time required is 10 nanoseconds. And at this negative edge, dhyan dena, at this negative edge, what happens? What is going to happen? What is going to happen at this negative edge? The next flip-flop becomes active, and before the next flip-flop becomes active, its input should be ready. Its input should be ready, and its input is equal to 10 nanoseconds. Its input will come after 10 nanoseconds. Matlab, let's say this is the T on, because duty cycle of the clock is not exactly 50%. So let's say this is the T on time period of the clock waveform, right? And we should know that this T on should be greater than, the T on should be greater than 10 nanoseconds. ये एकदम fix हो जाता है. The T on should be greater than, okay, 10 nanoseconds. Okay, ये जो particular gap है ना, this should be more than 10. Otherwise, what will happen? Suppose, let's try to understand. Suppose this is 7 nanoseconds. Okay, so what happened? Just after 7 nanoseconds, the clock is ready here, but the input is not ready, na? The input is the output of the combinational logic circuit, and that will be active only after 10 nanoseconds. So if the clock negative edge comes after 7 nanoseconds, then your input is not ready and there will be timing violations. Okay, the input is not ready, there will be timing and setup time violation also. So T on should be greater than 10 nanoseconds. Let's deal with this equation. T on greater than 10 nanoseconds. Now what is the value of T on? Okay, T on depends on the duty cycle. So for 40% duty cycle, okay, if there is the 40% duty cycle, I'll take you both the cases. I'll explain you both the cases. If there is the 40% duty cycle, then the T on is equal to 0.4 of the clock time period, and this should be greater than 10 nanoseconds. So the clock time period should be greater than 10 nanoseconds divided by 0.4. Okay, 10 upon 4 is how much? 2.5. So this is 25 nanoseconds. Okay, clock time period should be greater than 25 nanoseconds. If there is a 60% duty cycle, then the on time period, okay, is equal to 0.6, 60% of the clock time period, and this should be greater than 10 nanoseconds. So here the T clock should be greater than 10 divided by 0.6 nanosecond. This should be how much? This is 100 by 6, 16.67. But जो story है मेरे सामने, right, the time period of the clock greater than 25 nanoseconds, the time period of the same clock should be greater than 16.67 nanoseconds. What will satisfy both? It should be greater than the larger number. It should be greater than the larger number. If it is greater than 25, automatically it is greater than 16.67. That is what you have to remember. So the time period of the clock should be greater than 25 nanoseconds. Okay. So what is the clock frequency? Okay, that will be the maximum. See, this is the minimum. I can say T clock minimum is 25 nanoseconds. Okay, so what is the clock frequency which is maximum? Because they are the reciprocal of each other. One is the minimum, other is the maximum. Maximum clock frequency is 1 upon 25 into 10 raised to the power minus 9. Solve it up. 10 power 4, 40 megahertz. 40 megahertz is the answer. 10 power 3 divided by 20, rest is megahertz. 40 megahertz is the correct answer. Option number C. Mark. Okay guys, option number C is the correct answer. That is the 40 megahertz. That is known as the 40 megahertz. 40 megahertz. 40 megahertz. Okay. Chalo. Yes. A simple question here. Among the following four, the slowest ADC. What is the slowest ADC? Flash type? No, flash type is the fastest one actually, na? The flash type. Correct answer for the previous is C, 40 megahertz. Okay, Chinmoy? Right. The flash type is the fastest one. Slowest one is the integrating type. Simple factual question. Okay. Integrating type. Another one. If it is a 8-bit flash ADC, if it is a 8-bit flash ADC, what is the minimum number of comparators required? Okay, minimum number of comparators required. So answer should be equal to how much? 2 raised to the power n minus 1. Here it will become 2 raised to the power 8 minus 1, 255. 255. Option number C. Option number C for this one also. इसके लिए भी correct answer option number C चला गया. तो some basic question of ADC and DAC also. Next one, guys. Consider a 4-bit D2A converter. The analog value corresponding to the digital signals of value 0000 and 0001 and 0 and 0.0625. What is the meaning of this portion only? Right. Corresponding to the analog level, corresponding to 0000 is 0 volt and 0001, which is actually just the next count. In digital, it is just the binary, it is the next count, and at the next count, the analog voltage is 0.0625 volt. That means this is clearly an indication of the step size. Okay, this is just the next step. Okay, this is just the next step. So this is what? Okay, this will decide. This will write down. This is known as the VLSB. Okay, see, when only the LSB bit is high, or this is also known as the step size of the counter, or this is also known as the resolution, and that is 0.0625. Okay, the resolution or the step size or the VLSB is 0.0625. ठीक है जी. Now, what is the analog value corresponding to the digital signal 1111? So, sir, 1111, simple method is write down its decimal value. It's 15. So, for one step, the analog level will increase by 0.0625. So, for 15 steps, the analog voltage will be 15 into 0.0625. Solve it up, you are going to get this. Simple calculation, and anyways in the BARC at least you have the virtual calculator, otherwise we directly कर सकते हैं. Very simple calculation. Option number B, 0.9375 will come as the answer. 0.9375 will be the final answer. Okay. अच्छा जी. 0.9375. Next question. A digital to analog converter with a full scale output voltage of 3.5 volt. With a full scale output voltage, okay, full scale output voltage of 3.5 volts has a resolution close to 14 millivolts. Resolution which is close, approximately 14 millivolts. What is the bit size? Okay. Resolution. Okay. The resolution, or as I told you, it is also known as the step size, or in simple, the voltage for the LSB, only LSB bit, is approximately is close to 14 millivolts, and the full scale output voltage, now what should be the full scale? Like the previous example was 4-bit case, and 4-bit made the maximum binary count is 1111, which is 15. Okay, so the full scale, the highest voltage is 15 into 0.9375. So what should be the full scale voltage actually? So for n-bit case, suppose the bit size is n, the last count in decimal is 2 power n minus 1. It's actually all ones. It's actually all ones. Okay, the full scale will be corresponding to 1111, and this is n times. This is n times, supposing n bits, right? So this full scale 11111, all ones, in decimal it is 2 power n minus 1 multiplied by the step size. Okay, multiplied by the step size, right? There's a simple answer that you have to make. Okay, 2 raised to the power n minus of 1 multiplied by step size, that is 14 millivolts, is equal to the 3.5 volts. Take the proper precaution about the units. One is milli and another one is then. So 2 raised to the power n minus 1 is approximately 3.5 volts divided by 14 into 10 raised to the power minus 3, and this should be turning out to be how much? 3500 to cancel as 2.5, so it is 250. after cancelling 250. So 2 raised to the power n is approximately, because this was approximately because of the 14 millivolts, 251. So what is the nearest value of n that is going to match is 8. N is equal to 8, so bit size is 8. Okay, bit size is 8. Option number B. Correct. Yes, CR, I am good. How are you? Right, the correct answer is equal to the 8. Correct. That is the option number B. Yes. Yes, guys. Yeah. So time is already more than 1 hour. These are approximately 1 hour session. So due to timing constraint, I took few questions, only few questions of ADC DAC. You can practice little bit more, but the main intent was sequential circuit, because that is very important, and we did some good questions of sequential circuits also. Oh, hi Ramu, how are you? How was your exam? If you have written gate 22, if you are doing little good, you can message me in the Telegram also. Okay, so guys, a quick reminder that on this coming Saturday, 5th March, 8 p.m, Saturday 8 p.m, me and Ashutosh sir are going to talk about the gate 23 and gate 24 preparation. So you can update your juniors, or if you are also willing to prepare for the upcoming exam. So agar is baar acha nahi gaya, to what should be the correct strategy for the next time now, right? Now what should be the right time for you, and what are the tips and tricks by the BYJU'S experts? We'll talk about that. And guys, once again a reminder, this is just coming up tonight. Set your timer, guys. In another just 50 minutes, you can say, another approximately 50 minutes. Okay, the session low gate score. Okay, what IITs or IIC you can target? What IITs or IIC you can target here? Right? Okay. Right, guys. What branches, what IITs and IIC में कौन सी branches है जो आप low gate score पे भी target कर सकते हो? Yes, it is possible. Okay, not the top branches, but yeah, there are some branches that you can target. To get more updates about my sessions and the PDFs, you can just join the Telegram group GATE/ESE by Rakesh Talreja. And as I told you yesterday, PDF I forgot to share. So today's PDF and yesterday's PDF, both I will share in the Telegram. What is going to be the password for today's PDF? Let's keep it simple. Sometimes let's keep it simple. It's 0303. Today is 3rd March, na? Yesterday's password was told in the yesterday's class, and today's password is going to be 0303. The date 3rd March 0303 is the password for today's PDF. Okay. So guys, the next class that you have in this BARC and HAL series, okay, the next class that you have in the BARC and HAL series is the analog circuits. Sanjay Rathi sir will be taking, and that is going to be live in the morning hours, 11 a.m. Please take a special note of the timing, 11 a.m. And I think probably after that I will again come back for control system or EMT, mostly control system. So after analog, as far as I remember, it's control system. So we'll again connect guys in another 2-3 days to discuss up the control system questions for BARC and HAL, right? In another just 2-3 days. Okay guys, so yeah, that's it for this session. Let's connect again. Bye bye. Thank you. Stay safe. Take care. And first of all, we are connecting just another 50 minutes. Okay, a general session, and I'll give you the idea of the cutoffs also. If I'm telling low gate scores, so what are those low gate scores? What are those cutoff? We'll talk everything in this session. Bye bye. Thank you. Stay safe. Take care. Keep learning.